Welcome back to the session. For this session, we're actually going to be creating some codes for the operation, especially for the insert operation of the BST. Now, what I have in here is that I have already created here the structure of our node type for the element. So the BST actually contains the data that we want to store and also the informations because it's a binary tree. It's a kind of a binary tree, so which means it has the information of the left node and also for the right node. So, for example, if we try to see this representation at the side, we actually have this certain node that has that left information, the data information, and also the left information. Wherein both the left and right are actually pointing to another information of node, wherein it has also those three informations, the left node and the left, the data, and the right. So what we're gonna actually be doing is that if we try to insert an information in a BST, it's always inserted at a vacant space. And those vacant spaces we can try to see in this information is that we can insert those elements here at this the left information of the node 5. Also, we can insert the information also to the left and right node of the node 7 and also for the left and right of the node 15. So those vacant spaces are the only thing that where we can insert the data. So which means if we try to see all those null or empty spaces is possible for the data that we're going to insert. Now, how do you actually do the insert operation? So if we try to create the code for that, we need actually the information of the BST. So if we need the information, so I'm just going to call that one as an insert BST. And from my insert BST, we need the BST itself. And it's going to be pointer. It's because we're going to be changing some reference automatically from the original tree itself. And we also need the second information from here, which is the data part. So the data part, it actually contains the data that we're going to store, which is in our case, it's an LM. So LM type. So we're going to have here the LM type, and we're just going to call that one as data. So we need only those two informations in order to actually achieve the insertion of the BST. So I'll copy that one and paste that one in here. Okay. So when we try to insert the information, we need some kind of a way in order to reach those vacant spaces or those vacant addresses that we're going to save. So for example, this one or this one or this one or in the node 15 we have those two. So we might be able to. So we need to make sure that we will be able to reach that certain spot in order to do for the insertion. So what I'm going to have to do is that I'm just going to create here what I call this one a traversal that would allow me to hold these different values from here. So I'm going to call that one as BST asterisk trav. And we find a way that we will be able to reach that part. So how do we actually do that one? So it's kind of same as the singly linked list in the operation. If you try to see that if this were in the singly linked list implementation, you would actually try to traverse and try to move on to the next data. And but since we are already in the binary search tree or in the BST, we have two pointers that we can actually select which one would we go. For example, since we are following the BST structure, it should go that all the nodes on the left, so we follow that kind of property that all the nodes in the left are smaller in value by the root node or the parent node, and all the nodes in the right should be greater in value that of your parent node. So as you can see, we have here 10, which is 15 is greater than 10. And we can also see on the other side that we have 5 on the left side, which is lower value than 10. And we have also on the right side of 5, which is 7, because 7 is greater value than 5, but smaller than 10. So that's how it's actually been arranged, as what we have tried to discuss on the previous sessions that we have. Now, what we're going to actually do is just to insert them in the correct position. So we find a way of where it's actually being going to be inserted. So what we're going to do is that I will assign a traversal one the same value as my BST. So which means if it's the same value as my BST, uh, it would have been able to locate which position or which location I'm going to insert it. So I'm gonna have here some kind of a trav. So trav will actually get the value of B. So we're gonna have to store the value of B. And while we'll still not reach at that certain point that we're going to insert, we'll try to move into that position. So how do we actually do that one? So we try to ask whether the trav is not yet equal to null. So if it's null already, so which means it's possible to do insert at that position. So for example, if the BST is empty, then automatically we can just try to insert that directly into that node. It's because it's an empty list. So now we look for the position, and the other thing that we need to check is that if it is a unique element. It's because BSTs are a kind of a set. So which means if it's a set, then we only want to store one kind of an element or one kind of data into our uh, into that data structure. So we check here. So if it's not empty, so which means just like this, the BST is not empty. So if it's not empty, we try to check the information that we found inside if it's the element that we're going to do. Because if it's not, then we're not going to insert it. So asterisk trav pointer lm. So we go with the element part, the trav.lm, and if it's not equivalent with data. So if it's not equivalent with data, so which means we're not yet able to do that one. So we need to either check uh, which information we go. Is it on the left or is it on the right? Now we know that we go with the left. It's because if it's a higher value, if it's a smaller value, I mean, we go to the left. If it's a higher value, we go to the right. So we ask here, we assign the new information of our trav from here. So we say trav is equivalent to we check whether the information of trav is uh, lesser than the data that we're going to insert. Then if it's going to be lesser than, then we're going to be placing the pointer into the right side. So we get the address of this entire information from here. So we say there the address of the information in asterisk trav pointer right. Otherwise, uh, what we're going to do is that we're gonna be placing the information in the other side. So asterisk trav pointer left. So with this code from here, it would actually be something kind of like this. So if I have trav in here, so let's just say because this is actually the actual BST in main. So supposedly the BST that holds in here is B, which points to the information of your actual BST. And we have also created trav from here. And this trav is actually also the same value of your B as we have in the code. And we say there, if trav, this is asterisk trav. So is asterisk trav not equivalent to null? So which means this is not null because we contain some node information from there. So since this is not null, we try to ask trav asterisk trav pointer lm. So we're accessing 10 from there. Is the 10 the data that we're going to insert? So for example, let's just say we're going to be inserting here the value uh, 6, for example. Let's just say we're going to be inserting the value 6. So is 10 not equivalent with 6? So which means it's true. So it's they're not equivalent. So which means we are sure the next thing that we're going to do is to check whether our both of the left and right has the data or where we're going to be going. So is it on the left or is it on the right? So that's why we have the second statement in here that we check whether the asterisk trav pointer lm is lesser than the data. So for example, the lm part in there, the asterisk trav, which is 10 in this case, is 10 lesser than the value 6. So it's false. So once it's false, we actually will assign the new value of trav, which is the address of this. So we're actually getting the address of asterisk trav, so which means this is trav, this is asterisk trav pointer left. So this information, and we get the address of this data. So once we get the address of this data, we actually assign that the address of this information from here, we actually assign it with our new trav. So trav now, this time, would actually be pointing to the left information. So it's going to be pointing out to the left information. So once it's pointing to the left information, we go back with the while statement from there, that we ask whether if asterisk trav not equal to null. So which means we're asking here, this is trav, this is asterisk trav pointer, or asterisk trav not equal to null. So which means we see this information from here. So we've got this information from here. And since it's not null, we proceed with the next statement. Is asterisk trav, so trav, this is asterisk trav pointer lm, so which means 5. Is 5 not equivalent with the data that we're gonna be inserting, which is 6? So if it's not the same data, then we are true for that case. So we need to assign the value again with trav for wherever trav is going to be pointing. It's either be on the left, or it's either going to be on the right. So we ask here if trav pointer lm, so which means if 5 is lesser than 6, so it's true. So we assign the data to the right side of it. So which means the trav information in here actually now moves its information to the right side of that certain node. So we are now at here, so which means address of the asterisk trav pointer right. So we are now here. Now after doing that statement, we actually go back with the while statement from there. So asterisk trav not equal to null. So trav asterisk trav is pointing to this data from here. So we are actually pointing to this data. So once we're pointing to that data, the next thing that we're going to do is to check again whether if it's greater than or lesser than to that element. So if it's lesser than that element, then we'll try to move it left or either to the right. So which means we'll try to ask in here, is 7 or the asterisk trav pointer lm, so this one, if the asterisk trav pointer lm is not equivalent to 6. So which means it's not yet equivalent to 6, which means we're going to go deeper on that. So trav is equal to the asterisk trav pointer lm. So in this case, 7. Is 7 lesser than 6? That statement would actually be false. No. Is 7 lesser than 6? So we've got false from there. It's because it's a greater value. So what we do is that we assign it to the address of the asterisk pointer left. So this is now what's going to happen from here. So trav now points to this information at that side, on the left side. Now we ask again, is asterisk trav not equal to null? So we've reached to the end that we've stopped. It's because currently this time, the asterisk trav is equivalent to null. So we stop from there. And that's the time that what we will be able to actually insert that information. So I'm just going to add my the other statement from here. So if the asterisk trav is equal to null. So if we reach at the end of the null, it's possible to do the insertion. And we try to borrow for the memory. So we created here the statement here asterisk trav. So asterisk trav is equivalent to the calloc of 1. So we need only one space in there with a size of the entire structure that we're referring to. And that entire structure is actually referring to this one. So we need to have the size of the node type. So only one. Now we use here the calloc. It's because calloc automatically sets all its information, the LM, the left and the right, into an empty state. So since left and right, they will be set into null, and the LM is also set into a value called 0. So we have that one. And just to make sure that we're actually returning here a BST, so we type we typecast the entire expression of the calloc. Now, once we have created the calloc, that's the time that we're going to insert it. So if it's a successful creation, so not equal to null. So if it turns an address in there, then we are done with our insertion, and we're gonna be saying just to store the data because we haven't stored yet the data. So asterisk trav uh, pointer lm is equal to the data that we're going to insert. So you don't need to problem about the left and right information. It's because they are already set into null. Now, how does it goes with this? So if trav is equal to null, we are actually making here some kind of this pointer creating a space. So which means it's now creating a space in here that has that similar information. So it has that one, and it has this one, and it also has this one. So um, everything is already been set with that case. So it's empty. Now once it's empty, now the question here in line 27 is just checking whether if this is actually created in the memory. So if it's actually created in the memory, that's the time that we're going to say asterisk trav pointer lm is equal to data, and which is currently that we have 6 in here. So as you can see, if we try to free up already, we're ending with the inserting process of that and the function of that. Then automatically, as you can see, 6 was actually corrected, placed in that correct position.